Alright, moving on to the next section of this chapter, the derivatives of polynomial functions. First thing we're going to cover is what's the derivative of a constant. So, if you have a function, that's just a constant. So k is a constant. How's that going to look like? Well, it's just going to be a horizontal line, right? At k, whatever k is. It could also be below the x-axis if the constant is negative. So like functions like y equals 4, y equals negative 10. This is what I mean by a constant. It's just a horizontal line. And what's the derivative of a horizontal line always going to be? Well, the derivative, if you recall, is the slope of a tangent. And if you take any point on a horizontal line and you find the slope of the tangent to it, well, the tangent is always going to be horizontal, right? So the slope of the tangent is always going to be 0. So basically, if a function is a constant, then all that means is that the derivative to it is just it's just 0. Now we can prove this using the definition of a derivative. So remember that the definition of the derivative is the limit as h goes to 0 of f of x plus h minus f of x all over h. Now, if f of x is k, then f of x plus h is also going to be k. The y value is always going to be k, right? So the limit as h goes to 0, f of x plus h, that's just k, if the function is k, if the function is just a constant, and then f of x is also k. All over h, k minus k is 0. And then 0 divided by anything is just going to be 0. So that's how you prove this rule here, that the derivative of a constant is always 0.